Okay, so hello everyone. I'm here to, let's say, to move from the discussion that Federica made before about the importance of data and how they must shared and packaged together correctly in an interoperable form, and how they must not be lost. And I'm here to talk about the infrastructure that one has to realize behind, let's say, the scene in order to achieve such goal. So you can move to the next slide. We have started, let's say, so as I said, Federica discussed how do we manage the Nexus files. This was the starting point. And now what we have to do is that we have to make them easily accessible and easily shareable and available to everyone else in order to enable collaboration, which will be more or less the leitmotif of this presentation and of this whole work package. So let's say that who am I? I'm Ruggero Lot. I'm a physicist, and now I'm a technologist at Data Science Park, where I've been led to informatics and infrastructure as and I really like to tinker with novel technologies, as you might have seen with my hard time trying to share my screen using Linux and trying to combine it with Zoom and so on and so forth. So let's try to set up a simple situation. We are let's say, to give you a glimpse of the complexity behind the infrastructure that is not often seen by a scientist, and especially of the distributed infrastructure that is behind a certain instruments precision instruments that you have. That you might have in your laboratory. So if you bring a scientist and an IT guy, or let's say a technologist in the same room, where we have a TEM, you can move to the next slide. Where we have a TEM, they both see the same object, which is the column and the couple of screens and so on and so forth. But if we try to decompose it, what they are really thinking about is completely different. You can move to the next slide. So and what do I mean by different? Well, the scientist is very much concerned about all the scientific parts, so the column and the characteristic of the column, the cameras that are available, the kind of experiment that can be performed. Whereas from the other side, you have the technological parts that it's concerned to servers and what software they are running, how this software communicate with one another, which are the data paths that are in place, and how can we collect and distribute data to provide a homogeneous experience, let's say, to the users that come there and have to start to work with the first terminal, and then it has to move to the second terminal, and the data must be shared between the two, and so forth, and so on and so forth. And furthermore, all these must be integrated with the existing infrastructure. Okay, so this is not a situation. You can move to the next slide. We are not anymore in a situation where the experimental, let's say, setup is living in a vacuum, where it has its own local resources, local storage, that it has its own computational resources locally. All of these must be shared, let's say, with the rest of the facility. First of all, because we need to be in a redundant and high available situation, especially for the storage. And this is not achievable if we think at the single laboratory and the storage of a single laboratory. Furthermore, in order to enable collaboration, you have to be able to securely sharing the data that you have collected. And in order to do so, service needs to be in place, and those services are, let's say, hard to host on a per laboratory basis. So you try to conglomerate them in a single place. And finally, the computational resources that are required at this point in history to process the data are not anymore very cheap, let's say. And one single instrument cannot afford to have those resources binded to it, especially when it uses them on a spot-wise, in a spot-wise fashion, or to put it to extend this concept. Let's say it uses it only for a limited amount of time, and then for days or hours not used, then they can be leveraged by other facilities. And all of this is needed in order to let's say enable collaboration, and it's let's say easily and smoothly share the data between partners. Now, the design of such an infrastructure is an intriguing problem, and to do so, we started with the KISS philosophies. The KISS philosophies is somewhat what's drive, let's say, the Linux kernel development and all the Linux environment, and it's good because it tries to keep stuff simple and stupid. And simple stuff are nice because they are simple to explain, they're simple to maintain, and it's easy to get contribution to them. But as research tells us, from complexity arise complexity arise naturally from simplicity. So we can safely say that we have failed into maintain this simple, let's say, approach. And in moving to distributed infrastructure, that is the main requirement in order to achieve what everything that we want to, let's say, everything that you want to, all the goals that we have set for the project and for this environment, let's say, this distributed infrastructure requires some resource abstraction. Okay, why do we need the resource abstraction? Because we want to be able to perform resource partitioning. So we have this pool, this common infrastructure shared among all the laboratories, and we need to be able to partition this infrastructure. We need to be able to simplify the management part from a technical perspective. We need to be able to create scalable and reproducible environment that should be high available in order to not interrupt the services along during the experiment, for example, when you want to store your data, when you want to process that. And furthermore, we need to increase security. So this is the, let's say, all the complexity that arise naturally from simple elements. This distributed is the next slide. Sorry, I forgot to say. Well, yeah. From all these, there is this, all of this comes with a completely new skill set that is required. And from a technical perspective, every layer of infrastructure, every layer of abstraction that we include in our deployment lower the performance of the code that we developed. In particular, I'm trying to drive my attention, it will drive your attention to the kind of abstraction that are already in place and probably used by many of you. In the next slide, from left to the right, what we can see is that we have the simplest kind of abstraction, which I think everybody is aware of, that are virtual environments into a Python. If you can move to the next slide. That are virtual environments into a Python deployment. That is where you install your code and where you try to keep everything nice and clean for what concerns the dependencies and so on and so forth. This is nice because it's good on resources, so it's optimal. Let's say when we talk about resources, it's good on security. Sorry, this is not good on security. On the other hand, so it does not scale beyond, let's say, the single experiment of the single code that you might develop. It gives you optimal performance, just I already said, and it's very poorly scalable. So when we talk about a distributed infrastructure, that is what we would like to realize. This is not the way to go, or at least it cannot stay with us for a long time, in the long journey. Then the next step that you might be aware of is virtual machines, which is what is commonly used when we try to, let's say, simplify our development and try to compartmentalize our codes and our service that we try to offer for every kind of software, for every kind of process. This is optimal when it comes to security, of course, because this is a very basically every workflow runs completely separately. It's very poor. On the other hand, it's very poor on performance, and this is the problem that we will try to solve. That we solved when we moved from let's say virtual machines to container that are good on resource usage. They are very good in performance. They give us the same amount of security that virtual machines are able to have to give us, and they have the same scalability as the virtual machines do. In particular, let's say that if we focus on the performance, which is what people are most concerned about, there is this nice comparison of different. Next slide. There is this nice comparison of different technologies that allow you to virtualize your environment. In particular, here we have the Docker technologies, which is a container technologies in brown. We have the standard virtualization in violet, the column in violet, and different kind of code that we want to run in our environment. The code that I want to focus your attention on is the Fourier transform, which is the one at the center that stands for FT, where we see how only adding the layer of a virtual machine will take us more or less half of our computational power out and will reduce our computational power of a third. It's a specific case, but I think it represents the majority of the computation that it's done in this field. So this is what concerns the performance. When it comes to the now that you have understand that we want to move to an environment, a distributed environment that is built on top of containers, we need to understand which kind of software we want to deploy on this environment. And in particular, we have chosen a different set of, let's say, software for collaborations. On the storage side, we have the Mini.io environment, which gives us the S3 compatible kind of bucket to storage your file. This allows us to basically create what's called a vertically scalable storage that is horizontally scalable on this side. So as the experimental data grows, we can arbitrarily increase the space that is available to you, giving you the impression that there is only one single folder or disk, as you might imagine it, where you can store the data that you are producing. This is what vertically scalable stands for. Obviously, this is not possible in a standard environment where sorry, not in a standard environment, but in a non-distributed environment where you will at some point end up filling your single machine and you cannot scale on and you will need some technology to scale into multiple ones. And this is the one that allows you to do so since the beginning. And it's also secure from a point of view of the data communication and very simple to use. There are a lot of APIs to connect to it. And this is where you might want to store your Nexus file, or we choose it in general because you might want to store different kind of format files and so on and so forth. But when it comes to data visualization, which is the next step, it's where the Nexus really kicks in because it allows you, by leveraging different tools that have been already developed by different communities around the world, in particular we choose NOMAD, you can really browse the data that you have produced in a, let's say, user-friendly manner. And this is for what concerns data visualization. And for data visualization, we have data manipulation. For data manipulation, we hope that the main tool to achieve so would be, since we all work in Python, would be JupyterLab. And this should be, it's not yet, but should be integrated with the rest of the infrastructure. And finally, we have identity management. Identity management is one of the most complex points from a technical point of view, because you always need to perform correct authentication. So you need to be able to know who is connected to your software. And on top of authentication, you need to perform authorization in order to allow him to access the correct part of the data. To perform identity management, we choose, you can move on to a couple of slides. To perform identity management, we choose two software. We have a free IPA and Authentic. They serve two different purposes, or at least they work at different scales. The first one allows you to, let's say, provide the classical user experience in a Linux-based environment, while the second one allows you to provide the user experience that you would expect from a website environment. The glue between the two is still a work in progress, but we are working on it. The next slide. So are we there yet? The answer is almost. I've already partially answered this one. So we have done the design and testing of all the singular parts, but some integration are still missing, especially as I was saying on the IDM, on the identity management side. If you want to summarize the take-home messages, yes, data management is important. To enable collaboration, there are many, requires many moving parts, and all of those are essentially, we took the path to develop them in a distributed environment for multiple facilities at the same time, and this adds complexity but reduce costs and on the long run simplifies a lot of operations. And finally, developing in container is the way to go if you are developing new codes and you want them to be portable and you want them to be distributable, available, let's say, on a large scale, on the large public, and easy to deploy in other environment that is not yours. Finally, if you want to play with the complex infrastructure, I have put here a couple of links. One is to our data center digital twin, the one on the left, where you can try to play around and see if you can integrate your code inside a real HPC environment. And if you want, you can add the Kubernetes overlay on top of it, where you can try to integrate, let's say, more novel approaches into the distributed computing analysis. If you want to work on the Kubernetes overlay, since it is very and it is very early stages, so we can define this more as a proof of concept, please contact us. The other one, it's almost one-click deploy at this point, and thank you for your attention.